All right, hello and welcome. This is going to be our rational functions test review help video. Let's get started. Identify the domain and range of each. It should be all real numbers except for the two asymptotes. So we can recognize that these are transformations on our parent function y equals 1 over x. This one normally has asymptotes located at y equals 0 and at x equals 0. And now this graph has been shifted somewhere else using a, h, and k. And the ones that we really care about are the h and the k. So this domain here is going to be all real numbers except 4. All right, we have an h value of 4. That means we've been shifted 4 units to the right. All right, we cannot plug in the value of 4. It would cause us to divide by 0. That's right where our vertical asymptote is. The range here is everything except for the horizontal asymptote. There's no shift here, so it's going to stay at 0. So all real numbers except 0. Domain here is going to be reals, comma, x cannot equal -2. The range is going to be reals, comma, y cannot equal 1. The 1 has shifted us up 1. So this is a different way to write it. Be able to do both, or be able to, at least to recognize both for the multiple choice section of the test, either with the does not equal or by writing the word except. Question 4 is just multiple choice. It's not hard to pick the correct answer here. We're just looking for a graph that's been moved up 1, and this is a +1, so it's opposite of what you think, left 1. So up 1 and left 1, that's got to be D. But part of why I put this in here is now we can look at all the different values it gives us. A discontinuity at -1. Do we understand that? Do we understand why there's a vertical asymptote at x equals -1? Horizontal asymptote here, x-intercept here. Does this one make sense? It should make sense because if at the x-intercept, the y value is 0, so we can plug in 0 for y and solve. And then we got another example of domain and range. So don't just skip over this multiple choice. There's a lot to kind of learn here about this type of problem based off of all that extra information that it gives us. All right. Let's see. I think that's the last problem on this page. Next page. We can pick this graph really quickly too. I can tell it's got a slant asymptote because the degree of the top is 1 more than the degree of the bottom. This 3 is 1 more than this 2, and those are the biggest exponents. So I know it's got to have a slant asymptote, so it's got to be this one here. This is the only one that has a slant asymptote and behavior. But look at all this other stuff it gives us. We can learn from this why it has these values in here. Let's not just skip past this. Let's make sure we're reading the whole problem. After identifying all of these features, sketch the graph, well, select the correct graph. If there is a slant asymptote, write the equation for the slant asymptote below the graph. So to get that equation, we're going to have to do long division here. So the top, I'll put underneath my long division symbol. The bottom, I'll put outside. Let me clear a space here. Whoops. Show my work. I ask myself, what do I have to multiply 3x squared by to get an x cubed? Well, that's going to be a 1/3 x. Then actually do the multiplication. That gets me the x cubed. Multiply it here. That's going to give me a plus x. Let's subtract this away. Nothing, so these cancel, nothing to subtract from the x squared, so I'm going to have an x squared, and then the negative 6x minus x can be negative 7x. What do I have to multiply 3x squared by to get an x squared? Well, I have to multiply it by 1/3, so it's going to be 1/3 x plus 1/3. So let's take that off the top. You can stop here. Y equals 1/3 x plus 1/3. And that actually looks about right for where the slant asymptote would be so that the tails of this function can lie flat to it. And that's supposed to be written below the graph down there. All right. Simplify each and state the excluded values. Another word for excluded values are points of discontinuity. And another word would be holes and vertical asymptotes. These are really just factoring problems, plus you have to know a little bit about what to do with your final factored form. Let's just practice factoring these. Common factor on the top, I can take out a 3p from both of those terms, leaving behind a 5p minus 8, just 8. On the bottom, I can take out a 3p, leaving behind a 3p plus 1. All right, so we're going to have an excluded value. P cannot equal 0 because that would make this value here equal to 0, and we'd be dividing by 0. Also, 3p minus 1 or plus 1 cannot equal 0 because then this part would be 0 and the whole thing would be 0. The whole bottom would be 0. We'd be dividing by 0. So now we got 3p cannot equal negative 1. P cannot equal negative 1/3. So the simplified form is just this here after those cancel out, and these are the excluded values. I put a note in here to help you. You get the excluded values from before you simplify. So after you factor, but before, well, I should have said before you cancel. I mean, this is, maybe you could consider factoring a form of simplification. But yeah, you gotta set the individual factors on the bottom equal to 0 to get those excluded values. Let's take a look at 7. Make sure we can factor this here, and then we'll move on. Two numbers that multiply to be negative 18 and add to be 7. That's going to be 9 and 2, positive 9, negative 2. On the bottom, I could factor out a negative 1. That's going to leave me with a squared plus 6a minus 16. Two numbers that multiply to be negative 16 but add to be 6. It's going to be 8 and 2. Well, 8 and negative 2. So those will cancel, and our excluded values are a cannot equal 2, a cannot equal negative 8. And maybe to simplify, we want to move this negative to the top and distribute it, assuming that's what it's got in the answer key. It's going to be negative a minus 9 over a plus 8. All right, identifying the vertical asymptote. So these are factors on the bottom that don't cancel. In order to figure that out, you got to factor it to see what does cancel. So this one here, the top's already as simple as it's going to get. The bottom, I can factor out a negative 1. And then what remains could be factored into x plus 2, x minus 2. These cancel, leaving just a 1 behind on top. And this is the factor that doesn't cancel. So x equals 2 is the equation of the vertical asymptote here. 2 is the value that would cause us to divide by 0. Therefore, it's an excluded value. How it presents on the graph is as a vertical asymptote because it does not cancel out. And in this one here, this is already factored, so x equals 0 is our vertical asymptote on this one here. All right, wholes are factors that do cancel. So again, you've got a factor. A lot of these problems start with factoring, so it's time to get good at that once again. I can pull an x squared out of this, leaving behind an x plus 4. On the bottom, I can take out a -2, leaving behind an x cubed plus 3x. Let's see, I can take out -2x actually, leaving behind a 3 or an x squared plus 3x minus 4, and then that's going to factor to -2x. X, let's see, two numbers that multiply to be -4 but add to be 3 are going to be 4 and -1. 4x minus 1. So the factors that cancel, an x will cancel with an x, and the x plus 4s are going to cancel. So the values that made these 0 were x equals 0 and x equals -4. Those are the wholes of the graph because they canceled. All right, graph and state the equation of the slant asymptote. All right, a lot of things we need to do for this. To help us graph, we're going to factor this. But when it comes to finding the equation of the slant asymptote, we're going to work with this form here. But we'll start with factoring. I can factor in an x from the top, leaving behind an x squared minus 4x plus 3. I can factor out a -3x from the bottom, leaving behind an x and a -2. This will factor to x multiplied by 3, but add, okay, minus 3x minus 1. There we go. And -3x, x minus 2. So let's list off what we can tell. X's are going to cancel, so we're going to have a whole at x equals 0. This one doesn't cancel, so we'll have a vertical asymptote at x equals 2. The values that make the top equal to 0 will be x-intercepts, so x-intercepts at 3 and 1. And let's get the equation of that slant asymptote now. Doing it backwards here. The top goes under the symbol. The bottom goes outside. What do I have to multiply -3x squared by to get an x cubed? Well, that's going to be -1/3 x. That gets me my x cubed, as well as a -2x squared. Subtract that away. -4 minus -2 is going to be -4 plus 2 is going to be a -2x squared. What I have to multiply -3x squared by to get a -2x squared. I have to multiply it by positive 2/3, plus 2/3. So our slant asymptote is at y equals -1/3 x plus 2/3. We've got all these other features. Let's add them in. Vertical asymptote at 2. Slant asymptote starting at 2/3. And it's going to go down 1/3 each time, so it'll hit that point there. All right, there's our slant asymptote, -1/3 x plus 2/3. X-intercepts of 3 and 1 right there. Do that with my pen tool. 3 and 1. That tells me that this is curving in to these two quadrants here, lying flat to the asymptotes. From below the slant asymptote from negative infinity, went to the left of this one, disappearing at negative infinity, coming back in at positive infinity. Kind of like that. Let's add in, there's a hole at 0. And I think that's a pretty good graph. I kind of want to look at this one to see how well I did. Yeah, it looks about right. All right, simplify each expression. We got a multiplication, division, addition, and subtraction here. Well, let's jump into it. This here, I'm still going to factor the top just in case there's something that can cancel. Let me just factor the top to see if something can cancel. I can pull out a 5n squared, leaving behind an n minus 2, I believe. Let me double check that by just distributing it. Yep. So the n minus 2s are going to cancel, leaving behind this n minus 7 on the bottom. So for a total of 5n squared over n minus 7. That's for our multiplication one. I just want to double check into that one right. Yep. For division, we got a copy dot flop. Don't forget to factor. So we've got 9 over 2n, n plus 6. We flip this upside down. It's going to be multiplied by 2n over 1. These two n's will cancel. And I'm left with 9 over n plus 6. Final answer. All right, when we add, I've got to get a common denominator, but if you factor first, you might be able to shortcut it a little bit. So this here is going to be 3 plus 3n plus 4n over, I'm going to pull out a 3n from these terms here, leaving behind an n minus 5. Now I can see that I can get a common denominator a little bit quicker by just multiplying this one by n minus 5 over n minus 5. Common denominator, I can just add the numerators. I'll want to distribute that 3. It's getting a little messy, but it's going to be 3n minus 15 plus 4n all over 3n, n minus 5. And final answer, 7n minus 15 over 3n, n minus 5. Leave the bottom factored like that. All right. Short break for me. All right. Subtraction one, again, we need to get common denominator. Let's not miss the opportunity to cancel here as well. This 3 and the 6 will cancel. I could just be subtracting a 2x. And then to make that have a common denominator, I multiply that by 2x plus 6 over 2x plus 6. So I get a 3x minus the quantity of 2 times 2x plus 6 all over 2x plus 6. And we'll simplify from there. 3x minus 4x minus 12 over 2x minus 6. This will give us negative x minus 12 over 2x minus 6. Don't think we can do much more with that. Let's see, negative x minus 12. Number 16. Number 16 is this. What have I done here? Oh, this was still a 2x here. Oh, and that throws everything off. Oh, okay, let's fix it. So now we got 3x minus 4x squared minus 12x all over 2x plus 6. Combine those, we get negative 4x cubed minus 9x all over 2x plus 6. Yeah, that looks better. Oh, they factored a 2 out of the bottom because you're supposed to leave the bottom factored, so we should factor a 2 out of both of these terms. All right, let's skip to our complex fraction here. What I want to do is I want to just combine on the bottom first and then do copy dot flop. To combine these on the bottom, I've got to get a common denominator. That means multiplying this first part of the bottom part of the fraction by 3 over 3, and the second part by 2 over 2. And now I've got that same thing all over 3u over 6 minus 4 over 6, which equals u squared over 4 all over 3u minus 4 over 6. Now I can copy dot flop this, u squared over 4 times 6 over 3u minus 4. Divide these both by 2, we'll get a 3 and a 2 for a final answer of 3u squared over 2 times 3u minus 4. Which 3u squared over, oh, well, on this one they don't factor out the 2. Not sure why my answer key is inconsistent. I have to go talk to the executives over at CUDA about how they're generating these problems, because that time I did leave the bottom factored. All right, solving and then looking for extraneous solutions. Let's pick 2 of these. I'll try to pick 2 of the harder ones. Let's see, I guess the second 2 would be the hardest. These already have a common denominator. In this, you just have to multiply by x over x to get a common denominator. Here to get a common denominator, I'm going to swap out that 1 for a 5r over 5r, so that now I can actually add them together, which is going to lead to the equation r plus 1 over 5 equals, now that I can add them together, I'll combine the 5r and this negative 2r to get a 3r, so r squared plus 3r minus 24 all over 5r. Let's factor this here. We've got 2 numbers that multiply to be 24, but add to be 3. I'm thinking maybe 6 and 1 second. 8 and no. 6 and 4 doesn't work. 12 and 2. 8 and 3. It's a harder one. What else is 24 divisible by? Maybe this isn't one that can be factored. Yeah, I guess we're gonna have to deal with it not being factorable. It's okay. We'll cross multiply, see where that leads us. And what do we get? 5r times r plus 1, that's going to be a 5r squared plus 5r equals 5 times r squared plus 3r minus 24. Divide both sides by 5 to make that cancel. Now I've got an r squared plus r equals r squared plus 3r minus 24. The r squares cancel. I'll subtract 3r from both sides. Negative 2r equals negative 24. Therefore, r equals 12. Plug it back in to make sure it's not an extraneous solution. Let's see, 21, r does equal 12. All right, do 22. Let's find some white space to do that one. We got 4 over k squared. 4 over k squared. Let's come down over here. Equals 5 over k minus 1. So I need to combine these into a single fraction, so I'm going to replace this k with, or this 1 with a k over k. Now this here can become 4 over k squared equals 5 minus k all over k. We can cancel a k from the bottom here and this k down here. Let's multiply k to both sides. And we get 4 equals 5k minus k squared. We'll add k squared to both sides. Subtract 5k from both sides. Now we've got the expression k squared minus 5k plus 4 equals 0. This factors into k minus 4, k minus 1. So we get k is 4 and k equals 1. K equals 4, k equals 1. Let's see if either of those are extraneous. I feel like the 4 is, because this will be equal to 1/4. No, that actually does work. Let's try the 1. It's 4 equals, nope, they both work. So they're both good answers. All right, on to our word problems. Everybody's favorite. Arjun can tar a roof in 12 hours. Shanice can tar the same roof in 13. If they work together, how long will it take them? So if I do time divided by 12, that will be Arjun's contribution plus the time divided by 13 would be Shanice's contribution. Together we have to tar one roof. So now let's solve this. Multiply this side by 13 over 13, and the other side by 12 over 12. Add them together, I'm going to get 25t over 156 equals 1. Multiply 156 to both sides, divide both sides by 25, and I'll get 6.24 hours. Dan can paint a fence in 8 hours, so time divided by 8 for Dan. Same fence in 9 hours for Julia. We're going to paint one fence. So let's see, what are we going to get? Times 8 times 8 times 9 times 9. So it'll be 17t over 72 equals 1. Multiply 72 to both sides, divide both sides by 17, and we'll get 4.23 hours. A boat traveled 384 miles each way downstream and back. The trip downstream took 12 hours. The trip back took 24. Find the speed of the boat in still water and the speed of the current. So when you're going with the current, it helps you go faster. So I got to take that distance, 384, divide it by the trip down. We're going with it. So we'll do boat plus current equals 12. 384 divided by boat minus current equals 24. Now we've got a system of equations. So let's solve it. I'm going to rearrange this by multiplying b plus c to both sides. And to this one, I'm going to multiply b minus c to both sides. So now our equations look like this. We've got 384 equals 12b plus 12c, and 384 equals 24b minus 24c. Well, let's do some canceling. I'm going to double this one. 384 times 2 is 768 equals, if I'm doubling it, I get 24b plus 24c. I'll add these two equations together, so I'm going to add another 384 to get 1,152 equals 48b. Divide both sides by 48. And look at the speed of the boat was 24. Let's see, where do I want to plug that back in to solve the quickest? Maybe into this equation here. So 384 equals 12 times 24 plus 12c. 12 times 24, that's 288. So 384 equals 288 plus 12c. Subtract 288 from both sides. So 384 minus 288 equals that. Divide both sides by 12. C equals 8. Eight equals C. So I'll write this out. Just to finalize it. The boat could travel 24 miles per hour in still water, and the current was 8 miles per hour. All right, well, that's a lot of the review. Hopefully that's been helpful. And good luck studying.